at the turn of the year, where I've been doing a lot of hand roll passes as I tried some new tooling, and I was able to take something that was taking me several days to, in effect, a few hours, and enables you to write a compiler for a language in under 24 hours. I think that's kind of cool. And it must be true, because you can learn C++ in 24 hours. So why can't you write C++ in 24 hours? So we'll look at what I built later on. Let's dive in. So what this talk is not, we're not going to talk about how to write compilers the hard way. This is about how to write them the easy way, the quick way. I'm not a masochist, so this is not how to rewrite C# in 7 years. This is not all theory. It's not going to be that hard, but it's not necessarily perhaps the thing you will be able to just sort of drift through last thing on the afternoon. It's going to be a little bit hardcore. So what is the talk about? Well, it's turtles all the way down. You'll see that as we go. And we're going to look at abstract syntax trees, parsing, domain-specific languages, all the way through to interpreters and code generation. We'll look at generating IL and JavaScript, because that's cool, and machine code and all that sort of thing. Now, actually, the first thing we're going to look at is language design. And these are the kind of language families that I've played in. You've got C being a big bubble. So you have C# and Java derivatives, the curly brace syntax. Basics have been around and still exist. You've got an overlap here with the ML languages. Now, the ML languages are OCaml's derived from ML, Haskell is in a way, and F# derived from OCaml. And then the other side of it is the even older tree, the Lisp tree, over there, and there's still modern Lisp compilers in the form of Clojure. There's a little link to 7 languages in 7 weeks, which is a nice book. So, we're not going to spend long on language design, because I believe it's considered optional these days. But we'll look at the different approaches that we can take to language. In effect, all the languages have already been written. So the first approach is a very popular approach. And actually, what we can see in most languages is if you have any computer science background, you're not going to write a popular programming language. It's better to not have any clue whatsoever and just start writing something. So this is why starting in 24 hours is probably the best place. So what we need to do is start with a personal homepage and extend it from there. There's number one. JavaScript, a couple of weeks, and then put it out there, and oh wow, look, it's the biggest language out there in the web. Brilliant. Or we could just take another ad hoc approach, is we're not really sure what to do, so let's just put everything in, and you have Scala. So that's the ad hoc approach. It's a good one. Then we've got copy and delete. So we copy an existing language and we remove functionality. And I think there's a lot of value in this, and obviously it makes our job a little easier because we don't have to implement all the previous functionality. So Java's a classic case of this. We're taking C, we're removing multiple inheritance, pointers, all those gnarly things, goto, and we have something that's a little bit easier, less sharp. J is actually taking APL, and APL had all the keywords were Greek symbols, so it removed the Greek symbols. So that's kind of maybe a step in the right direction. Go's actually gone even further than Java by removing classes, win. Just structures and extension methods. So not even less sharp edges to cut yourself and all the performance that goes with that. So that's the copy and delete. And then we've got copy and add. So I'm going to put C# in this category. So C#1 was a copy of Java. And what did they add? goto. It's still there. So Java took it out, they put it back in again, and to be fair, they added events, and later on they added a bunch of really nice things like link. F-sharp's a copy of OCaml with some added features, and Haskell is a blatant copy of Miranda, where they've added monads, which Scott was talking about, and type classes, and yeah, that's pretty much it. So even these modern languages are literally just copying one, tweaking it a little bit, and adding a few bits. So we don't have to spend long on language design, just decide which one you're going to copy, and whether you want to remove things or add things. So we're going to head over to the code in a minute, but I'm going to show you some slides of what I'm going to do. Rather than drop you straight in on a full compiler for C#, I'm going to drop you in on a turtle-like language based on Logo. How many people here have used Logo? So it's not everybody, but it's a really simple language well, on the outside that kids used in the 70s and 80s for learning programming. It was fabulous. It's one of the first things I used. Actually, the problem it had was it was so simple and for producing beautiful shapes and things, nobody actually saw the real language. It was actually really beautiful. So we'll look at a bit of the beauty of Logo later on. So the turtle language, we have some basic constructs. Just with these lines, I can produce this pretty pattern over here. So what we have is repeat 10. It will repeat this block. This block will turn right 30 degrees, and then repeat 5 times, going forward 54 pixels and turning 72, and that draws this beautiful pattern here. So it's it's a lot of fun for kids, and for adults too. So if we look at this language, we have a repeat command, right and forward. So we have very few things. And we have these blocks, okay? So if you were thinking C#, they would be curly braces. It's the same thing, right? And we don't have semicolons, we've just got white space. First thing we're going to do is have an abstract syntax tree for our turtle. So this is the very first example. I'll do this in big form, we'll go into the code. Now we're using F#'s union types here, and we can actually describe what we've just seen. We have commands, forward of argument, turn of argument, and repeat takes an argument, the number of repetitions, and a list of commands. And here it's recursive because you have repeats inside repeats or forwards and so forth. And actually, we're almost there to doing reasonable things with that few lines of code. And from here, we can extend out our AST to deal with procedures, functions, addition, and so forth. But this is if you want to do it in 24 hours, you want these union types. And then after that, we can pattern match it. So this is the hardest bit for me in the presentation. I now need to switch from this mode into Visual Studio mode, so please bear with me. There doesn't seem to be an easy button for this. Tom's probably knows. So, Windows P. Excellent. Now you can't see that, can you? That's good. So the code I just showed you, that's legitimate F# code, ready to go. That's our abstract syntax tree. I've taken the liberty of writing an interpreter against that. But what I want to show you now is that we can construct that abstract syntax tree inside F# using that tree to model the code we had. So here I'm going to draw a circle, repeat 36 times, forward 10, rotate 10. Oh, hold on. There you go. So that's using the AST and then interpreting the language. And we can take that piece that we just did and there it is. Okay, so it's actually not that big a mapping between the AST and logo itself. So, with that underway, the next piece I'd like to do is actually take logo code as a text file and pass it into the abstract syntax tree, because I've got the interpreter to draw it. So let's do that. Let's have a look at that. So what we're going to use for this is something called fparsec, which is a parser combinator library. Just make that bigger again. Now this makes real easy work of creating a parser, and I'll show you in action so you can believe me. So I'll just push into the interactive window the parsec DLLs. I'll create a test function, and we're ready to start parsing. Now I don't have to do a compile run cycle, I can just literally try out my parser as I go and compose it up. So the first command is forward space 10, right? So in fparsec we'll write forward equals, we're expecting a string with the name forward, followed by some spaces, and a float. How easy is that? Right, so if I test that out, now if I just pull this down a bit, what we've got is success 10. So it's actually pulled out the number 10 from that. So all good so far. One of the things that's really hard about writing a parser is how do you deal with error cases? Now, the nice thing about fparsec is it's got your back. So I'll just assume I haven't done that. What I don't want you to be able to do is forward 10 without a space, because that could be a function, right? So if I write this, it's actually saying success 10. That's not what I want. I want an error, right? So I get instant feedback. I can go and fix that. I'll put spaces 1 on that, which means expecting at least 1 space. Now here's the killer feature. Hopefully you can make that out. What we've got now is the parser's given us an error on that line, and it's got an arrow pointing to the part that was expecting the spaces, and it's saying expecting white space. I am done. There is nothing to do here. All of the hard work of doing those gnarly error messages is solved for me. So this is fantastic. Okay, let's take this a little bit further. So I've got my forward command, and I want to take that and create the AST part. I've got that forward case. So all I need to do is like so, and I now have success forward 10. So what it's saying is, if forward works, then take the number that's returned and construct the forward case. So that's all good. The next thing I might want to do, if you're a hardcore logo programmer, you get bored of typing forward all the time, right? So you want FD. So it could be FD or forward. Okay? Now this is actually really powerful. So to do that, all I need to do is say, if I see the string FD, or I see the string forward, and some spaces and a float, I'm good to go. So let's try that like this. And we have success 10. And if I do it like this. Now, clearly, that was nice and easy. It's beautiful. These symbols are a bit weird, and it does take a while to go, but there's some really great samples for it. And it does kind of make sense. We've got this ORing here, and we're piping the values through. But using that syntax means that, in effect, the parser for the function I'm doing is almost the same size as the function. It's just a line of code, right? And then I can write parsers for all of the functionality in my language independently, test them out in the REPL, and then just compose them together, and I'm out of here. So that's what we're going to build up to now. So forward was probably, you're going, oh, that's too easy. So let's have a look. Let's go down a little bit further. and we'll have a look at a more complete parser. So, sorry. I have to keep doing this for a while. We've got forward, left, and right. Okay, so again, that's pretty easy. Now this is where it gets a bit gnarly. We have a command, and the basic commands, forward, left, and right, they're fine, right? They can be next to each other. But repeat is a command, but it's recursive. It could be, we have repeats inside repeats. So the way we break out of this is there's a little helper called create parser forward to ref, and that just says, I'll define repeat later, and just trust me on this, and later on you fill in repeat, and you can break out of that recursion. So that means I can then just say, a command is any of those four things, and this is cute. For our repeat, we'll have blocks. So in C# it would be curly braces, for logo it's square brackets. We just say between open and close, we expect many commands separated by spaces. Again, that was pretty sweet and easy. And then repeat expects a repeat command followed by at least one space, the count, some more spaces, and the block. Actually, we don't need spaces between the count and the block start because square brackets don't interfere with numbers. And yeah, we're pretty much done. What I then do is say that repeat I didn't implement, here it is. There's my implementation for repeat. And we're done. So let's try that out. Well, let's try out part of it. Great, so there's my parser. Now this is the code in Logo. We pass that. That returns the abstract syntax tree which we used earlier. So we're already there. Sorry, yeah.
Just a quick one. Why do we have p-repeat and p-repeat import?
Yeah, that's so we can split up the reference to p-repeat and the actual implementation because I'm forward declaring it.
Where's the relationship established?
It is actually just, it's really nasty. It's mutating the implementation, so that's how it works. But it's only a little line of code, and I'm not pure, sorry. I just like to get things done very quickly, and they work and have nice error messages. So, yeah, we've passed that out, and now we can do alt enter. So I've actually passed that code. It was just a few lines of code. The logo, and now we've got an interpreter. Let's take this a little bit further on, because you're probably all saying, yeah, it's a bit of a toy language. So what I'm going to do now is extend out to functions. Logo has this syntax to declare a function. So actually, if you look at it, Logo is probably the most terse language out there for doing that. You compare that to C#. I kind of like this. So we have an end to declare the end of the statement, and we also want to be able to pass parameters, and they're delimited by this colon, right? So we're actually moving on to a more fully fledged language at this point. Okay, so let's have a look at the parser for that. Well, we'll look at the AST first, and let me just get the zoom right so you can see that. So we're just extending a little bit over our previous AST. We've got a forward, left, and right. Now, for artistic reasons, I need a random position, so I've just dropped that in there. And you'll see why. It's very, very good artistically. We've got our old repeat, and we've just added two new cases. Call is the ability to call a function we've defined with a name and an argument list. And a proc allows us to define a procedure with a parameter list and a list of commands. So our AST, again, is incredibly easy to extend up to defining and calling functions. So we'll just push all of this into the interactive window. Don't do this at home, kids, but I do like just having everything when I'm playing all in one file, and then I separate them out into separate files later on. It just means I can iterate a bit quicker. So, and I'm trying to do this in 24 hours, not 7 years. So, we're now moving on to a more sort of full implementation. We want to be able to parse identifiers. For identifier, sorry.
You didn't actually put the thing in.
Oh, did I not get? Oh, thanks.
You snagged a bit of the trailer comment.
Did I actually delete anything?
No, you had too much highlighting.
Oh, okay, thanks. Winning. Cheers for that. Code review. Good. So, yeah, identifiers are kind of key. So for identifiers in Logo, it could be a letter, and actually that's a minus sign. So negation's not really an option here, but apparently that was good in the 70s. Then we can have an identifier character inside after the first character, and that might have a digit. So that's where our forward 10 would have been an incorrect pass, because we can have a function called forward 10 that goes forward 10. That would make sense, kind of. So that's that part. The colon parameters, that's quite easy. It's a colon followed by an identifier. Done. Moving on a bit, you've got usual forward, left, right stuff. Let's look at this one. For our, let me see that. For defining our procedure, in a base case, we've got a header, the to and the name and the parameters, the body and the footer, which is the end. And we define the parameters as many parameters, which we saw earlier, beginning with colons separated by spaces. So this is one line. The header starts with to, some spaces, the identifier and the parameters. Body is many commands. And footer is end. So done. Procedure's done in about 6 lines of code. It's just amazing. And this scale, I'll show you later, this scales out to languages like VB and C#. The same technique. So, I guess that's pretty much our parser done. Let's push the parser through. And again, the nice thing, as I'm building this up, I can just literally take a small fragment, try it out, try the failure cases out, and see if it works. And then if I'm happy with it, we go with it. So here's our code. And the big reveal's coming in a second. Let's suspend it for a sec. So our parser, which is what we've actually been working on, has actually taken out, built an abstract syntax tree. Those are the procedures, and there's the call. So if I run that, art. That's my flower garden. Random placed flowers. Cool. So hopefully you've seen parsing with a parser combinator library is just really quick and easy, and you get error handling for free. You can try it out in a REPL, and literally half an hour, you can have your basic language spec'd out. It's just huge. So the next part of writing a compiler is deciding where it's going to go. Now, you could just say, interpreter's fine for me, and that's good in many cases. Actually, we'll just have a look at that interpreter, because it's quite easy. So the interpreter takes the abstract syntax tree, and for each part, it says, is it forward? If it is, forward the turtle. If it's turn, we change the turtle's angle and add end to it. And if it's a repeat, then we just have a recursive function, returns the turtle if it's got to 0. Otherwise, we perform all the commands and subtract, and we just recursively run until we get down to 0. So that's your interpreter. Now, compilation is almost exactly the same. All we do is we match over the AST, and instead of doing the actions immediately, we emit the actions either to IL code or JavaScript or Java or whatever compile to language we want, and we're done. And that just, instead of doing the commands directly, it emits code to do those commands. So we'll have a look at that. So last week at Build Stuff, I ran a 7-hour course on how to write your own compiler in the day, and we had the group from scratch build their own compilers for Logo, and they compiled out to JavaScript, and we got partway into compiling out to IL. So I'll show you what we did. So what we're going to try and do is something a little bit more fully featured than what we did before. This is a Logo a function, recursive function, to draw a fractal tree. So we're going to pass that and compile that out to JavaScript first. And actually, compiling out to JavaScript is really nice and easy compared to IL, because you can visualize the code that it's emitting. And so the first part I do is to kind of write out what I want it to pass to, and then in effect just copy and paste those lines into the match statements and just string format them, right? Done. And that's all there is to it. Now, there is this kind of hidden thing that we'll try and gloss over. No, we'll talk about it a little bit. Actually, a lot of what a language is not the language itself. It's all those lovely libraries that go with it, right? So, you know, a huge part of the value of things like C# and Java is that you have this common language, common framework, that you don't have to go and find another file routine that's incompatible with 5 different platforms and all the other libraries you've got. You just go and get it, and it just works. So we need a library for Turtle. So I just knocked up this in JavaScript itself using HTML5 canvas. Just do a little bit of trigonometry. We've got forward, back, turning, a lovely random position. And then I dropped in the Logo code and then wrote what I thought would be the ideal JavaScript to match that. So we have a recursive function, and the stop maps to a return out. And then I just went about doing that conversion. So here, we've actually had to extend out the abstract syntax tree to do addition, subtraction, and so forth. But again, it's not particularly hard. So this is pretty much heading on towards full language. So when we look at, say, VB or C# later, it will look like this, almost identical. We'll have arithmetic instructions, comparisons, logical ands and ors. We'll have literals, arguments, variables, and then we'll be able to compose in these expressions. And again, like C# and VB, we'll have a set of commands or instructions that take an expression. So instead of taking a number for forward, I could take a parameter, I could take 5 times 5, I could take a call to a function, and so on. And that's our abstract syntax tree covered there. Call proc that we saw before, a few little things for our beautiful artistic design, and make is actually the same as var in C#, right? So we're just defining a variable, and we need to put in our lovely if condition. Stop is our return statement, so in effect kind of go to, but not as gnarly. So that's all good. I'll start dropping this into F# Interactive. It's exciting, isn't it? We're going to see what is that tree going to look like. So what I did was instead of running the parser every time, I just took the result of the parser and dropped it in here so I can just go. So I took the output from F# Interactive of the parser, dropped it into my code, because I want to go fast. So here is a two JavaScript compiler for Logo, right? It's about 20 lines, 30 lines of code. If we have forward, then we call our forward function. So the functions are really easy, okay? For repeat, I'm going to use a for loop, and I'm just going to omit the block, right? So that's easy. So literally, we're just using string.format, right? This is to emphasize that. string format is all you need with pattern matching. Yep.
How come for the repeat you're using string.format, but for the functions you're using string.f?
I guess I am not consistent. Good question. So, yeah. So I am using a mixture of whichever I felt was a good idea at the time. Yeah. Sorry. I am dirty. But dirty's good, maybe. Here we're going to put vars out for variables. The if condition, again, very simple. Stops just to return, and so on. Again, for arithmetic, I've been a bit lazy. I didn't want to have to do one for plus, minus, and so on, so I just return out the in-between string, and then I put the left side, the operator, and then the right-hand side. Again.
Assuming the JavaScript's arithmetic is correct.
Yeah, well, everybody else seems to just go with that. We will look at, we will take the mickey out of JavaScript a lot more later. Yeah, the one to enjoy. So if I just run that, we'll just push that in once so you can have a look. And I'll run that again. So what I've got is pretty close to the ideal code that I initially drafted out. And again, it's just a few lines of code. Right? Now, that, again, remember, we'll see later, this abstract syntax tree is not far away from many of the languages you're using. So compile to JavaScript's looking very easy with pattern matching. Yeah?
Do you need to handle precedence of arithmetic operators?
Yeah, so when you're doing compile to JavaScript, dealing with precedence of operators, the lazy, easy way of doing everything is just wrap everything in brackets. Right. The other thing that you have is collisions between keywords from one language to another. So the approach I'm using is, and this is quite a common approach, is to just put underscore in front of everything. And for all my local variables, I have like a underscore A, underscore B, and so on, sort of like a naming scheme, so I can keep them nice and minified. But it just gets a new one each time. Right, so but again, that's just one simple function. You just say, get me a new unique variable for this one, because I don't know what JavaScript's going to do. Does JavaScript know what it's going to do? Let's make it easy for it. I can either just use a template to put that in, or I can just copy and paste the code emitted from, which I've done already, and then we can just start the browser from the interactive window. And because it's JavaScript, this is going to take a while. Even after I've, come on, you want to let me view this. There you go. Let's just make that. Isn't that amazing? So we have taken, thank you, we have taken a logo, we've passed it, and we've converted it to gnarly JavaScript, so it can take 5 seconds to render a tree. And is that Atwood's law? Anything that can be written in JavaScript will be written in JavaScript. So, something else that you might want to do is compile out to IL code, and we'll have a look at that now. So the first thing I'm going to do, like I did before, is write a little library. So I need to do, and I've actually written this in C#, why not? It's a good imperative language. So I've got code for doing forward, turning, so that's the big imperative win there, and for opening up and showing. So that's my library side, and then I can emit those functions like I was in JavaScript, but I've got to use IL to do it. So just kind of a quick side thing, this kind of IL emit I'm about to show you is, you might do a compile to IL, but you might be doing something where you want to do some sort of optimized, you've got a tree and some sort of expression, you want to get some optimized IL code to go faster. then you can use this technique. You maybe even skip the parse bit. So I've used code emit in a number of places. I've got a BDD, or automated exceptions test library called TickSpec, which compiles out given when then statements into IL, so you can actually debug on the lines. And there's no code behind because it's actually going straight to IL. And you don't need a Visual Studio plugin either because it just does it there and then. So that's kind of cool. I've also got a mocking library based on MockQ, and MockQ in effect emits IL for your classes that you're mocking in your methods. So I've created one for F#, because F# has features that C# doesn't. And to be able to mock them, I needed something. And then I made a mistake, don't do this, of asking people what I should call it on Twitter. So F# begins with an F, so I have a library called FOCQ, which is used heavily in the enterprise. And hopefully by the end of the year you can look forward to version 2, which will be FOCQ2. Anyway, after that little aside, let's before we go into the hardcore subject of compiling to IL. We've done a little bit of humour. So here I've actually just dropped the parser in. So that's a parser you've seen before. And we're only going to do a small subset because I don't want to make you this is an hour talk. But in effect, we can create an assembly and then we emit IL instructions into that assembly. Most of the things we're going to do is an emit and invoke onto our library. So all I need to do is match forward and emit the invoke for forward with the parameter. That's easy, one-liners. And now for the head-boiling bits. The repeat 0, we can just say we don't need to do that. And actually, this is the kind of optimizations that are easy in compilers. Let's say we had an add of 2 literals, 5 and 7. Instead of emitting the code for that, we could emit 12, right? So you can do compiler optimizations to sort of reduce those sets. But let's look at repeat, or turn away if you like. IL code is actually fairly close to C# code. It's kind of a one-to-one mapping. So what we need to do for our repeat is we need to have a counter, and we'll declare a local variable for our counter, and we'll load it in the value I4. An integer with number n. So that's the instruction LDC I4, and then we store that in a location. The location being our local variable. So that's in effect var count equals n, right? Where n is a number. We'll define a label because we're going to do gotos. We're going to just do a repeat block, right? So we need somewhere to repeat to. All we then do is emit our commands. Okay, so that will just go recursively back up to here. It could be a repeat within a repeat. We're going to inline everything. We're going to be super optimized. And then what we'll do is we'll, sorry, I was a bit sleepy this morning, decrement the repeat count, so we just load in our var, our count, and subtract 1 from it, and then store it away again, nice and easy. And then we compare it with 0, so we load in the value, we load in 0, we compare with greater than, and then we branch true back to the label. So, yeah, I just did that straight off the bat. No, I didn't. It's really easy. The way you do it is you just write the C# code that you want, right? And then you go into something like ILDASM or Telerik just decompile. You look at it. Literally, you just copy it into your code, and you just do IL emit next to it. And where there's a parameter, you put the parameter. It's not that hard. Compiler writing, it's just easy and fun. So, I compile out all of that code. Now here's some nasty boilerplate which I recommend you just find and copy off somebody like me, where we define a dynamic assembly, modules, and all sorts of nasty things. In effect, what I'm doing is just defining a program class, a main method, and then dumping everything into it, which seems like a pretty good policy for this small snippet. And I've compiled out to my program. So let's just run that. And that is, yeah, cool, thanks. So that has parsed the logo, compiled it to IL code, and that was a lot quicker than JavaScript, but I didn't do a fractal tree, so maybe I'm cheating. Okay, so let's have a look where we are. So we're about 40 minutes in. Now let's go up a gear. So I'll keep hinting that what we're doing here with logo isn't that far off what we might do in a larger language. So I was teaching, when my son was about 6, him a language called Small Basic, which is a cut-down basic aimed at children. It's actually really popular. It's just nice and cute. There's only 14 instructions. And it has a logo capability built in. So it's fantastic for kids, or at least that's what I thought. And so we were playing with that, and then we got to the point where it doesn't have functions. So we had our lovely castle, but we wanted lots of castles. And we wanted to parameterize the size of the castles. So at that point, we just switched over to F#. And but it was still just dragging on me a bit. So the library for the wonderful thing about the most wonderful thing about Small Basic is its library, and you can call that from C# and F#. And I've used that for teaching adults introductory programming because you just get something on the screen that's exciting. But it was grating on me. So back in the beginning of the year, I decided to write a parser and compiler for Small Basic and add the functionality that I would like to have used, which is what I'm going to show you here. So this is the way I went about it, and it took about, overall, a few train journeys, probably adding it all up with thinking time, about 24 hours, which is where the title for this talk came from. And I used every cheating method I could under the book to achieve this. I want a compiler. I don't want to do a paper or something like that, or string my employer along for years. So here's the thing that pretty much the same arithmetic and comparison operations we had before. This does support the full minuscule small basic language. And then we have our value types. Now here comes the JavaScript fun. Small Basic has a more advanced type system than JavaScript because it's got integers. Wow. Right. So if you take integers out of here, you have JavaScript's type system. Wonderful. So that's great. So it is more powerful than JavaScript here, at least in part. We have the same expressions that we had before. We have function calls. We can get values at indexes. Actually, I'll probably just push all of this through rather than going through bit by bit. We've got fors, if, else, end ifs, whiles, end whiles. And there's some sort of obsession at Microsoft. There we have the minimalist instruction set for a programming language, and they put GoTo in. But I love GoTo. It reminds me of writing machine code in the 80s. So what we have is, I'll just kind of take a little bit of a whirlwind tour. What I've done is, from that abstract syntax tree, written an interpreter. So instead of going straight into the parser, I want to make sure that my abstract syntax tree is roughly in the right direction before I put work in there. Although it's easy, it's easier just to get the interpreter going. And then instead of just jumping straight into the interpreter, I wrote an internal DSL, right? So an internal DSL is a DSL written inside the language itself. And here's FizzBuzz. And it almost looks like BASIC, right? So at this point I was like, do I really need to do the parsing? Yes, I do. But at this point, because I can do FizzBuzz, it obviously must work. It's the hello world. So let's see that running. So we don't, oh, hold on, every time to reset. Just do that again. I'll just run the program. So we have our AST and we have our interpreter already, but we don't have a parser. We do have an internal DSL, and there you go, lovely FizzBuzz. So that's run interpreted ways. Now I've got an interpreter, it means that when I write my parser, I can actually just test it out. So that was my next step. So this was another train journey. And again, where we saw it as an internal DSL before, we've got our full, wonderful, small basic syntax there, which is quite VB-esque. But in fact, it maybe, in some ways, it's a little bit shorter than our common languages. We don't have to put var anywhere. But that's because everything's global. So you win some, you lose some. Oops. Like other languages we may have seen. So it's the same AST. And then if you can remember those weird hieroglyphs we had before, pretty much the same kind of thing going on. We've got here we've got a parser for number formats. We've got our string literals. And our identifier. So the identifier was one we used in Logo. Here we've got the string type, so we'll have string literals are just between quotes, right? Nice and easy. There's a operator precedence parser built into fparsec, and so I copied this out of the tutorial, which is nice. And I've written a lot of handwritten parsers. Doing the operators is one of the hardest parts of a parser because it is a tree. But it's all done for you. So again, a lot of time saved there. And also we get the error messages for free. You can set lots of nice parameters about the associativity and priority as well, so you can get it just the way that you want it. So let's just keep going down a little bit more. Let's take on for loops. Again, it was really easy to compose. Start with from, which would see a for, followed by a set operation, a to, which would see the to keyword followed by an arithmetic value, a step. So for pset, we would see something with something equals something else, right? A step would be an arithmetic operation again. And we pipe those three together. So from to, and there's this other operator optional, because sometimes people use step, most of the time they don't, so it's optional. And if it's not specified, so there's no step, I just put in the literal one, right? So that's for loops in a much bigger language. So I'm gonna, that's the interpreter as before. Let's just give that a go. Oops, every time. I just need to, there's a collision with the last library, all right? Let's just run that again. Great. And I'll just run it again. So fizzbuzz. So we've passed and run. Fizzbuzz. The next bit is pretty much what we did with Logo, and that's to write a compiler. So if we look at that, make that bigger. So it's the same kind of match that we had before. We have these extra types, but we just emit for our literals the opcodes. So that's pretty easy. There's even a emit string function, ld string. Let's go and have a look at something fun. I love goto. So there's an opcode for that, opcode sponge. And actually what you'll see if you're looking through the code here is that there's pretty much a one-to-one relationship between instructions and IL code. So, I mean, C was originally a thin kind of abstraction over assembler that was cross-platform, and what we're using with C# and Java is really just a lineage of that. We're very imperative, very low level, in the instruction level anyway. Okay, so I've got all of that, and we save out the program. So I was really excited when I got that going, because I can compile something like this. I'll just show you. I downloaded a game from the Small Basic website, and I could compile it and run it. So let's just do that. So that's running. This is running through my custom compiler, and it's turtles all the way down, right? And I am playing a game in my talk, sorry about that. It relaxes me. Hopefully it relaxes you too. It's not the best game in the world, but that's kind of cool. But there's still that niggly part, which is I wanted to have functions with parameters. So I've added that. It took about an hour. And those are actually not globals, they're local to that function. So then I could finally do the castles with my kids in the small basic language, although in the text editor. That's cool. But then I was like, well, what I really miss is pattern matching and tuples. So, and small basic didn't have select case either. So I thought, well, this would be nice. So here it is. This is small basic with a few extensions, which took a few hours to add first-class tuples and pattern matching to the language, which VB and C# don't have. Oops. I'd be embarrassed. So here we're constructing a tuple with mod A, 3. So the modulus function we just defined, mod 5. So again, we're doing fizzbuzz. If we got 0 and 0, that's the 15 case, we do fizzbuzz. 0 followed comma, underscore is anything. So it does handle wildcards. It's pretty much pretty close to a basic version of, say, Erlang or F-sharp's pattern matching capability. And it's faithful to VB style. VB's actually got more powerful select case than C#. You can have like 1, 2, 3, and it would match those 3, where in C# you'd have to do case 1, colon, case 2, case colon 3. It also, you're able to do things like less than 1 or something like that in VB. So it is actually more powerful. That's all, I'm faithful to that. I do all of that and support pattern matching. And this supports tuples within tuples within tuples. It's tuples all the way down. So arbitrarily complex. Cool, so let's just run that. Right, so I'll just run, have I got it? Oh, I haven't copied it over. Maybe you'll just have to trust me on this one, but it does work. If it managed to run the whole other program, then I'm running a bit short time. So, the last one I wanted to quickly show you was, so I took the small basic abstract syntax tree, and I was stuck on the train. It was snowing in January, and over the course of 2 hours, I made an AST for C# and did the parser. And it's surprisingly similar to small basic with some extension points, some sort of gnarly bits. So you've got infix and postfix, ternary operators. We've got very similar kind of statements. The expressions are almost the same with the addition of these and casting. The statements, we have a few more constructs, try catch, ignore, no. So we have all that kind of stuff. Go to was just a copy and paste over from small basic, as were most of these. And then you've got these horrid things, these modifiers that confuse children. Public static void main, that's obviously how you do your first function. That's what my 8-year-old did a talk actually on F# at the Cambridge User Group last week. He was composing 3D objects in OpenGL, but I was talking to him after, and he's like, "That JavaScript stuff, those braces, who thought of that? That's just weird." So anyway, out of the mouths of babes. So that's the AST done. And then I just took elements from the parser. And bish bash bosh. It was a little bit longer because we have to define things like classes, interfaces, delegates. But pretty faithful. And here's our full enterprise C# piece of code. Right, so we've got our enterprise namespacing, interfaces, all that lovely stuff, and it passes. So, sorry?
Did you put pattern matching?
No, I haven't extended the language. I think we could look at this as a copy and delete. But I think that's valid, right? That's the way that's what the cool kids are doing these days. So, and compiling to JavaScript, of course. Copy, delete into JavaScript. So, yeah, if I run that, that will actually compile that out to the AST. So, coming towards the end now. Let's speed things up a little bit. Sure. Let's just show you that actually running so you can see that. Yeah, so like you saw the AST previously, this is the AST in all its glory. You can imagine this is why it's quite hard to parse C# trees. They don't come out that well. Okay, but it isn't that bad in F# to pass over them, as we've seen before. Cool. So I'm going to go out to the slides, and we'll just cap off where we've been. Okay, so that was where we ended. Actually, another little story. We did a how to write your own parser in an hour at the F# Functional Londoners user group, which is based at Skills Matter. We've got about 800 members. We had quite a lot of people come down, 50 or 60 people for that. And one of the guys had written his own logo parser in that hour with the graphics and so forth from scratch. And he took it home, and his kids, 5- and 7-year-old, started drawing shapes with it, which was nice, you know. And they were using this parser he just knocked up, and the library just knocked up in an hour. That's kind of sweet. I showed you that the compiler actually isn't just a toy thing. I can take any small, but it's actually completely faithful to the small basic language, but also adds powerful pattern matching, select case, and function types. This is a cleaner version of the AST. Now, this is kind of interesting. In our imperative languages, we have expressions, and we have these imperative instructions. With functional languages, not so much. Functional is just kind of an abused term. I guess the other way of looking at it is that expression-orientated languages. So in effect, we just have expressions, no instructions. So it's easier. Okay, and here's one. Neil, if you'd like to stand up and take a bow. There's Neil. Neil actually wrote a compiler. I don't know if it was 24 days, but it's quoted 2 weeks. 2 weeks. Oh, sorry about that. Well, we could edit the slide in a bit. Yeah, I got this lovely picture of you, Neil. I hope you appreciate it from the website. Just to kind of labour the point, so Neil's managed to create a C# compiler using Lex and Yak within 2 weeks and compile out to IL code. Again, it's not the full compiler, but again, you don't want to do that. Why would you put all those? Why would you put goto in? Right? I don't know. So it didn't have null. That's kind of a fair game as well. So hopefully you've seen compiler writing is fun. Using off-the-shelf tools makes it really easy. You don't have to spend years, and you can get quite a long way. Programming languages like F# and OCaml with pattern matching capability make it really easy. And you're seeing companies like Facebook using OCaml for things like Hack and for their compile to JavaScript side. It just makes life a lot easier. Why do it in imperative code and spend years on it when you can just knock it up in a few hours or a few weeks? Even if you're not, even if you have to do it in an imperative way because you're going to bootstrap the language, why not get it started quickly, prove your point, and then move on? Also, you've seen, potentially you don't have to use the parser and the compiler. You might just have a parser and an interpreter, or just a compile out some abstract syntax tree that you generate into IL for super cool high performance. And we'll just finish up with some resources. For those of you who haven't seen F# before, I hope you enjoyed it. You can see it's pretty damn powerful, but also the syntax is a little bit different, less curly braces. The easiest way I found to get into F# is the F# Coins. It's a project on GitHub. It's a set of failing tests, and each time you make one of the tests pass, you learn a new part of the language. It takes an hour and a half, 2 hours. That's a lot easier than reading a book. And once you've done that, you should find it pretty darn easy. If my 8-year-old can do it, it can't be that hard. I think the hardest part is actually unlearning with anything, is actually unlearning the way that you did before. And once you've done that, then it's easy to learn. But that unlearning is actually harder for us humans than learning, or takes longer. Once you've done that, there's a wonderful website called tryfsharp.org with lots of samples and tasks to do. And you've actually got IntelliSense in the browser with F#, and you can do cool things like call Hadoop and plot charts directly in there. So fantastic place to go once you've picked up the syntax. And now we can do books. There's a lot of resources for books out there. I'm going to point out, I haven't done a walk all the way over here yet, programming language concepts, which is used at universities in Scandinavia for teaching programming. And it's all the samples are in F#, and it has examples on how to write your own mini-C compiler, garbage collector, things like that. It's really cool. And it's only about yay big. They are about 250 pages. They chose F# because they wanted a nice short book with sort of samples.
No, Peter never writes for long books.
Okay, you know. Well, yeah, no, he did well there. It's an excellent book. A lot of people have been recommending Book of F#. Functional programming using F# is also used by undergraduates, and it's nice in that it has tasks at the end of each chapter. So you can really sort of test your learning. Thomas is in the room. Thomas's book is still awesome, so that's good. And a collaboration book that will be coming out soon, which we've been saying for probably a year now, but we mean it now, is F# Deep Dives. And that's not like the other books. That's actually about a chapter dedicated to success stories of people building real valuable projects that have made lots of money, and how they were done, and what went well and what didn't go so well, which I think for me was the kind of book I was interested in reading, and that's what we've got. So buy the book. Great. And more selling, sorry about that. If you want to learn more about F#, fsharp.org, just go there. We've got how to get installed on Linux, Mac, how to do GPU, machine learning, all those lovely kind of things, all in one-stop shop. Where the F# Foundation, which owns fsharp.org, is a legal entity now, charitable status in the US. That's really exciting. In April, we've got a conference dedicated to F# at Skills Matter. I believe the tickets are only £100. So if you want to learn more, that's a good one. And if you want training, pop over to the F# Works for your team, because you want to bring them all up to F# after the talk. F# Works. So I've probably said enough now. You all follow me though, right? Yeah. Good. Any questions? Excellent.
Is the code for your turtle example available?
Yes,
Yes.
it's all on my blog, which is currently under a denial of service attack. But I will, trailford.com blog, and hopefully I'll get it back tonight or tomorrow morning. It went down sometime early this morning. But yeah, all of it's up there, and the samples are actually, the turtles on Small Basic are on FS Snippet. So if you just go there, you can find them. without my site being online. And all of the samples here will be made available online. Any other questions? Really? Convinced then, yeah? Good. I'm hoping to see more compilers, because what the world needs is more compilers. Sorry. Yep.
What about more advanced concepts from, say, functional languages? Does it scale up to?
Yeah, absolutely. Yeah, I mean, in a way, by dealing with an imperative language there, we've made our lives much harder for us than a functional language. Yeah, people, if you go into the hash F# tag or look through the F# blogs, pretty much hello world in F# is a compiler. So yeah, we're a bit weird like that. But yeah, you'll see examples of things like scheme, mini, F#. In fact, in the book there's a mini functional language example. So it does, yep. Lisps are actually incredibly easy because they're almost an abstract syntax tree already. So there you go. Am I the one standing between you and beer now? If so, you can clap and you can go. Thanks. Cheers. Thanks so much. And I'll hang around for a bit if you have any questions you didn't want to ask anybody.
When the video comes out, we should send the link over.